Following on from the previous video, we were trying to find the shortest distance between a given point and a plane. So when given an equation, we can easily obtain this point here, and we can easily obtain the normal vector, which will be given by this. And well, if we know a given point and we know this point, we can easily obtain this vector here. We can easily obtain this vector here. So we need to project this vector QP, we need to project QP onto our normal vector. So the shortest distance will be given by this scalar quantity here. Okay, so the shortest distance will be given by this. So now I need to remind you or how to project a vector, how to project this vector in the direction of our normal vector, and we need to obtain the scalar quantity here. Okay, so let me just remind you how to project one vector onto another. So we've already done this, so this is a reminder. Suppose you're trying to project the vector u onto the vector v. So you projecting u onto v would then give you this vector here. So this vector here, well, basic trigonometry would tell you that, well, the length here is given by the magnitude of u. So basic trigonometry would say that this length here, the scalar length, would be magnitude of u, okay, times cos theta. So this length here, is given by this. Now, because you want to preserve the direction, so you know the length here is given by this. Now, if you get the vector v and then divided by its magnitude, so let's say this vector this has a magnitude of, let's say, 7. So if you divide it by 7, then you're going to get a unit vector. So this really tells you the direction, and then times the magnitude. So the combination of the two would then give you the magnitude and the direction. Now, so when you're trying to project u onto v, you have two choices. This route will then give you the vector itself, or you can go the other route, which I'm going to tell you later, and that will then just tell you the scalar quantity, the magnitude. Because in our case, we only care about the magnitude. We only care. So this is our normal vector. This is our vector QP. When you project it on here, because we want to know the shortest distance. Because we want to know the distance, we only care about the scalar quantity. We only care about the scalar quantity. We don't care about the direction. We only care about the scalar. We only care about the scalar quantity. So when you project one vector onto another, if you want to preserve the vector, the direction, and the magnitude, this thing here will give you the direction and the magnitude. Remember, this thing here gives you the magnitude, and then this gives you the direction. So the combination of the two will give you direction and magnitude. Now, looking at it the second way, so you have two choices. You can go this way, which will give you a vector, or you can, or if you only care about the magnitude, then you would go in this direction. So remember this. I've asked you to memorize this many times, so you've got to know this by heart. So basic trigonometry here will tell you that this length here will be magnitude of u cos theta. So if you know this length, then you can work out this length. So this length here will be given by this. So if you times this by the magnitude of u, that will then give you this. So now from here you can jump to here, because remember, this is the dot product here. Yeah, this is a dot product divided by its magnitude of v. So that will then take you. You can actually jump from here to here, because if you look at what's going on here, if you take the dot product, so let's just imagine it as like this, one vector. So you taking the product u v, so this is u v 1 1 u2, v2, and so on. If you look at what's going on here, when you take the dot product, it's this times this, plus this times this, plus this times this, and then overall, then you do, so it will be this times this, u, v, 1, 1, plus this times this, and then plus this times this, and then divided by its magnitude. Its magnitude is a scalar quantity. It's just a number. So when let's just say it's 3. So this is what you're doing. You're taking the dot product and then overall divided by 3. Well, when overall divided by 3, you can actually do this. Hang on. So hang on, bear with me. So when you take the dot product and then overall divided by 3, you can't just do this. You can't just do this. Divided by 3 in here, divided by 3, divided by 3, and then u1, u2, and then this will give you the same effect. So think about it. From here, that will allow you can get from here, you can actually push this into this vector here. But the point is, this thing here will give you a scalar quantity. This is what we're interested in. We could obtain this, but we don't want to. We only care about the distance. So we only care about the scalar quantity. So to work out the shortest distance, then simply perform this. Get the unit vector, because what it's saying here is get the vector v divided by its magnitude. So if you look at this, let's imagine this has a magnitude of 7 divided by 7, then that will then give you your unit vector. So this thing here will be your unit vector. So this thing here will be this unit vector here. Will be this unit vector here. So get the unit vector and then dot it with a vector u. So going back to our example, if you want to know the shortest distance, obtain your normal vector, and then work out obtain your vector q p. So that will then give you this vector here, and then project it onto your normal vector. That will then give you this length here. Well, to work out this, all you need to do is this is your normal vector. Obtain the unit normal vector. So get the vector itself. Work out the magnitude. Let's just say the magnitude is 7. So you cut it into 7 equal pieces. Well, you divide it by its magnitude, and then take the dot product. So take the dot product. So something like this. So I will give you an example. You see what I mean? I will give you an example in the next video.